Okay, let's try these three problems and mostly just have a little confusion thrown in terms of conversions. Plane is flying at 200 meters a second for 3 hours. How far has it traveled? Express your answer in kilometers. So a lot of students will miss this, all right? And you're just going to come up with 600 meters because you just didn't pay attention that there was a difference here. If you write it out with your units, you may spot it, and you can earn part marks till here before you carry this mistake on. So this is why we like to see the process, because your numerical answer is going to be wrong now if you don't catch it. Your setup is correct. You'd get 2 out of 3. How do we fix this? Well, the first thing we got to do is rationalize the time. We either turn this divide by seconds into hours or the hours into seconds. Much easier to do this. 3 hours times 3,600 seconds. You will get an answer of 2,160,000 meters. Then just chop 3 zeros off and you're here. I can get grade 9 students to do this almost in their head, providing I don't show them the formula. If you think about it, the answer is reasonable. But you need to demonstrate the steps. But I'm telling you, grade 9 students can do this if I just put it on the board and let them figure it out. As long as you say these words, 200 meters a second for 3 hours, most people can do it. It's when you're trying to remember, when did I get taught this, that you'll trip up. Maximum speed of a snail is 5 millimeters per second. By the way, there's a grammatical error in the sentence. I challenge you to look for it. I should have highlighted the 5 millimeters per second. How long would it take the snail to move 2 kilometers? My real question is, oh my gosh, I've seen snails after 4 or 5 meters, they start running out of that snot they leave on the pavement. And try to imagine this. If you had to glide naked on the pavement and you had to exude snot and spit to slide on, how much freaking snail chapstick would you need to go 2 kilometers? The snail would probably have to drink gallons of water to make this journey. Anyway, it's a simple use of our time formula, but we've hit 2 metric prefixes. And I don't know what kind of stupid mode I was in to put C here. I should have just put M. You know that the K is hiding 3 zeros. The millimeter, this milli, is hiding minus 3 zeros. So divide by 1,000 is minus 3. What I put the centi here for, I don't know. I just wasn't thinking that day. So this is what's going to happen. The 2 kilometers turns to 2,000 meters. The 5 millimeters, this divide by 1,000, just appears right here. I mean, look at it. It's so much simpler to have times 10 to the minus 3 than M. Okay, because if you have this, you'll think M&Ms. You'll be like, oh, M&Ms, I got to go to the store, buy some food, but I got to do my physics homework. You divide these two, you get 400,000 seconds. And you can convert it into days, but do a little math in your head. One day, it's like 100,000 seconds. So this is like 4 days. Okay, we'll do it. Maybe 5. Okay, so yeah, that seems like can't possibly seem reasonable, because when have you ever watched a snail? So you just have to now trust your math. This one, every student will get this far. 1,200 meters in 2 seconds. But then you slam into the, how do I do meters a second to kilometers an hour? And I got the long way and I got the short way. I'm going to show you the long way, and then from then on you can use the short way. So let's do meters a second to kilometers an hour, and we'll start with an analogy. In slang, if you say, I made 3 grand this term. So, it's my own sense. In slang, if you say, I made 3 grand, and I'm missing my closing quote, this term means times 1,000, the grand. So this is $3,000. The slang grand functions the same as kilo in metric. Rarer terms for money include the C note, which we would call hecto. Yeah, hecto for 100. Sawbuck, which would be deca. The bill size we call denomination. You routinely convert between them, but once upon a time you struggled with it. I remember the very first time I gave someone like a $1 bill as a kid and I got like 75 cents back. I was like, where's my dollar? Where's my dollar? So old terms are fin, sawbuck, C-note, grand. 3 of these mean you're over 60 if you use them. Only this one has survived. But in metric, we have all of these. K, H, DA. Notice, not metric. There is no multiple for 5. Okay? So really, we do this. The $5 bill would not be allowed to play on a metric playground. And there is no prefix for number 1. So if you understand this, you understand metric. So let's take a look at this. 3 times this is 3 times 100. 3 times this is 3 times 10. This is the count. This is the multiplier or denomination. This would be 3 hectodollars. This would be 3 decadollars. Okay? Someone drops 3 20s on the table, you would immediately go, 60 bucks. Okay? The 3 is not the total. It's the multiplier. Now, let's say we want to convert between denominations. So let's say I give you $300 in metric. That would be hectodollars. And we wanted to switch the denomination. So I said I want it in tens. Well, now that you've been given a smaller denomination, you're going to have to increase the count, okay, to match. So when going from hecto to deca, we would have to change the total up here, or we risk not having the same amount of money here. So if this side goes down, this side must go up. Makes perfectly good sense with money. That would make it correct again. Okay? 3 of these and 30 of these are the same amount. Okay? Then I gotta fix that and like, yeah, okay, I'm confusing myself. Yeah, 3 times 100 is not 300. This is like $100 denominations, 10. Sometimes there's quite a delay between me recording these things and writing them, and then I can go, wow, I could improve that layout some more. Now let's go back to a rifle bullet, 600 meters a second. What are we going to have to do to convert it to kilometers an hour? Well, the first part, and I got no arrow here. Let's get over that part. Meters a second. Let's convert this meters a second to kilometers an hour. So the first thing we want to do, I'm pulling the meters out over here. Okay. I want to put the letter K on that. I want it in kilometers. But if I put the K here, it will actually make the answer 1,000 times bigger. You don't sit there and say, hey, that $3, can you give it to me in grand? Would that be 3 grand? No, because it would turn it to $3,000. You have to undo it. So if we want the K to attach to this, we must undo what it does, or we will have changed the answer. So to convert meters to kilometers, you divide by 1,000. You've been doing that your whole life. Now what about the seconds? When they come down here, you know an hour divided by 3,600. Okay? That's 1 second. Now, when we put the two together, meters a second changes to that to make it kilometers an hour. I'm going to drop the units, focus on the numbers. Then the numbers we invert and multiply. And we are finally left with 3.6